times. Okay, let's do this. So this is the Space Game project. We have our requirements down here at the bottom of the right pane. We're building a console application using .NET Framework, the Star Trek Warp Formula, which is roughly encoded right here. This will have at least beginnings of a compelling story. We'll start with a player who's age 20, and we'll continue playing the game until they are 7 years old, they quit the game, or they run out of money. So we'll have to determine a starting amount of money based off of our compelling story. We'll have at least 3 planets that the player can travel among and trade goods and services, and a per-planet economy, which will mediate slightly the cost of varying items between planets. So, as per my usual, I'm going to run a mostly top-down design here. And this won't be the ultimate epitome of object-oriented design. It will not be the ultimate epitome of C#-based design. I probably won't be using much or many, if any, properties. No interfaces. I'm going to try and limit my inheritance as much as humanly possible. Basically only the stuff that is covered up through the enums and structs chapter in the C# step-by-step book. As per usual, I like to get out of main as soon as humanly possible. I dislike main. Well, actually, dislike static a whole bunch. So we're going to try and get out of static scope as quickly as possible. We'll do that with a new app. Well, IntelliSense is starting early today. And we'll call the run method here. Note that this is exactly the same as saying, wow. Good job, IntelliSense. Oh, that's word wrap, that's why. Well, this is what I get for going with the thin screen. You should be there. Perhaps you're here? You're not there. I may have to send it to my wider screen to find the IntelliSense button. Stand by. Apparently I've lost my IntelliSense button. Great. What the heck, IntelliSense? Well, that was the IntelliSense button. The heck? I would like that to be nicer than it's being. Regardless, we'll continue along. So this is exactly the same as saying app A equals new app, and then saying a.run. There's no difference here between this and new app.run, like that. The only difference is that here we have to keep track of a variable, and here we don't. Other than that, completely the same. I'll go ahead and use the new app.run because it's a bit more terse. So starting from this, we can create a new application. We can generate that class in a new file by hitting Control Dot or Alt Enter, or right-clicking on the app and choosing to do the quick actions and refactorings. We'll create this in a new file, which will be over here in Solution Explorer. We'll have to go over to it. This gives us app. And we could also have built that run method from in here using that Control Dot one more time. It just generates this new app.run that we want, which is awesome. We do get a default constructor out of the deal. I'm not sure why it builds that, honestly, other than that we are calling the default constructor here. You would think it would just stick with the default provided to us by C#, but apparently no. So I'm going to go ahead and move this to public because it doesn't really need to be internal. Internal just means that it can't be accessed from outside this assembly, but we won't be trying that, so I think it's a bit more clear to go with public in those cases where we need it. Okay, so in our run method, we're going to do a standard event loop, which basically means that we're going to run a loop until a user chooses to quit or there's another quit condition. And we can encode those directly into this loop. So we want to run at least once. We're going to use a do loop. And we want to run that loop while the quit button hasn't been chosen. bool quit equals false, because we only want we want this loop to continue to run until something has changed. We never want this to exit on the first go unless the user has given us some sort of input. So, well, let's think. There are a few steps we may want to do to get here first. So let's refactor this out. I'm going to select all this, hit Control Dot, and it will allow me to extract method. So I'll extract that out into an event loop method, because at the very beginning of my program, I want to be able to do a little bit of intro type things, where I can print out to the screen some messages that describe my compelling story, and then start the event loop. And that'll be our entire run segment. So all that stuff that we just wrote is still down here in event loop. It should work perfectly fine. It can't be static though, even though IntelliSense thinks it can be. So we'll just say play intro. I'm going to say for the sake of argument that my intro is going to be just a few screens of text that are separated by key presses. And I haven't quite decided yet which type of key press I want, but I will probably just make a user input and I'll work with it from there. Some sort of a user input method. So let's see. Things we want to do, we just want to console.writeLine a few times with, we'll say 3 screens of compelling story just for the sake of argument. And between these things we want to clear the console. And there. And we'll wait for that user input as well. So we'll actually rename this, call it elicit input. Because I like the word elicit. And again, we can use the Control Dot tool to automatically generate that for us. So let's see, we'll go with, I like read key, so let's go with read key this time. Read key returns a console key. And so we'll call return console.readKey.key. So if we run this now, well, it should run forever. So let me comment this line out right here. Okay, so we have compelling story number 1. We press any button and nothing happens. Because I typed compelling story number 1 3 times. Dangers of copying and pasting. We'll run that again. Compelling story number 1, compelling story number 2, compelling story number 3. I just pressed space between each of those screens, and it continues through. I imagine that any keys would work, and it does appear that way. Let's, for the sake of argument, well, why not? We're going to have to make this pretty at some point. So let's just go ahead and add in a little bit of text at the bottom of the screen that says, press any key to continue. I think that'll work. So wow. And we will, I think we can put that at the bottom of the screen. So it'll be console dot set cursor position, and that's going to be 0 on the left, and it's going to be console dot it's buffer height. Largest window height. No, there's a get window size, if I'm not mistaken. Let's see. Window height. That'll work. Console.window height. That might be beyond the end. Let's try -1 just for the sake of argument. That's not bad, but that might be caused by that. So if we just console.write, Ah, there we go. Beautiful. And then I believe there's a key we can set in intercept that will, or in read key, excuse me, that will allow us to not print that key to the screen. Yes. So intercept determines whether to display the pressed key in the console window. True to not display the pressed key, otherwise false. So we'll put true here, and that should give us beautiful. Absolutely beautiful. Love how my message and the standard console message are the same message. I'm going to leave that, I think. Okay, so we can now press any key to continue through our list here. I'm actually going to change this. We're going to change this to we're going to input a string. Input equals, well, no, that'll be prompt. And we're going to set that equal to just the colon character to begin with. No, please. There we go. And so the default prompt will look like that, though we don't actually allow any key input, so. I like that a little better. Just a little better. See if that actually does flash a key, because that might be compelling. Nope, it doesn't, so it's not. This is much more of an experimental, go with the flow kind of process for this program. It's a much larger program than the task list that we did previously. It's a bit harder to keep the whole thing in your head, so it's nice to spend a little time meandering around the state space and really determining exactly how you want to do all the things you want to do. Though I will say I'm going to run out of water long before I'm done. Okay, so in these cases, we don't actually want to use the standard default prompt. We'll go ahead and put a prompt message in here. And we can control.that to create it. That will be a local prompt. Well, that didn't work out at all, did it? Put it up here. There we go. And we'll set that equal to press any key to continue. Okay. So now I need a compelling story. Any suggestions? Not necessarily known for my fiction writing. Let's see if we can get word wrap turned on here. We'll only need it for these text things, but it'll be nice to have. Word wrap. Beautiful. I guess interstellar is all one word. Undo. Interstellar space. Okay. We're the captain of a space cruiser, the slowest vessel to sail. Make as much money as you can in your measly 50 years on Earth. Let's see, you're a merchant of questionable business practices, exiled from your home planet Earth. I love it. It's going in the program. On planet Earth. And we'll say you captain a space cruiser, slowest vessel to sail interstellar space. Well, it's not on Earth, is it? Your measly 50 remaining years. We'll go with that. I actually want to put this into a new file, so let's go ahead and do that. We'll make this a part of a scripting class of some type. We'll maybe even make it a static class. That should work. Will you let me do it? It won't let me do it. Ah, what a pity. Let go. Thank you. Yes, I got that. Thank you. And we'll call it story.intro. See if it'll do that for us. Generate class story in a new file. Internal class. Call this public static class. And oh, that's annoying because I'm using illicit input in here. So I actually need that to exist. That's not a problem, of course. We'll make this a part of UI, which will also be a new class. We can do that with add up here. Go down and choose class. New class, that'll be UI.cs. And so you can see I'm kind of breaking things up into their areas that they affect, let's say. Let's hop over to story. So intro in this case is part of the story. And so I've broken it into its own story class. And illicit input is technically a UI function because it is part of the interface with the user. And so I've gone ahead and put it into a UI class. Is this necessarily the best way to do things? Maybe, maybe not. But I think it's going to work for now. We're going to make both of these static methods. This will be public static console key. The reason these are public static is that we don't really use any... There we go. We don't really use any capabilities of the program. We don't store any data that are associated with these. All we're really doing here is calling, really, methods that are already in static classes. And we could go and track down system.console. In fact, we can just hit F12, and we can see that console itself, so console containing console colors and beeps and all the information about the size of the console window and write line and write and read line and read key and so forth and so on is part of a static class. So all these things are static methods. And that's again because they don't really impact any data in the process of them running. They just hang out here and do one thing and do it well. And all that data is available statically. So same idea here. Let's add that in there. Beautiful. This needs to be public static void intro. And then we'll make illicit input available as a UI field. Go away, stream health. You're bothering me. So it'll be UI.illicit input and UI.illicit input and UI.illicit input. Why'd you do that? Cool. So this is our story intro. Now in its own nice little location. We've got that. We've got this, which I'm still happy with. And we have program.cs, which can go away now. Okay, so let's save all this. And we will commit that as if applied this commit will write the intro and the basic tools, basic UI tools. Beautiful. So we can leave UI behind for now. I think that's the only thing we're going to need from UI. We may still need system here, so I'll leave it. And we can probably close story for now. Well, let's think. Let's think. So we've gotten the main story written. The next thing we have to consider is how we're going to set where the entry level, or where the, I'll call it a level, where the first place you come, the level, if you will, is when you start the game. So it's a bit of a difficult thing to do. I want this idea of a location. This occurs in one of the 2 examples I've made thus far of the space game. And I think I want to stick with it. I like the idea of a generic location. So, well, let's think about planets real fast. How far can I go with this without using inheritance heavily? Well, let's see what we can do. Let's see what we can do. Because really all we have to start out with is the ability to make a message about the planet that we're on. So let's talk about planets first. I'm going to want to be able to do something like current planet dot. Oh, let's see. Well, let's just write out in pseudocode what it is that we want to do. Pardon. Okay, so in pseudocode, we want to start out by print the current location. We'll start with that, and we will print a description of that location. And then we will provide options to the user regarding things they can do. Then we will, well, we'll elicit input. And then we'll handle that input. So these things we can just go ahead and write because these abilities already exist, or at least have easily guessed names, let's say. So var key equals UI dot elicit input. Spell elicit with 1 L? I think it does. Or is it 2? It is 1 L. So why did I draw it with, write it with 2 the other time? Oh well, what can you do? And then we can say handle input key. And of course, the way that I usually do things is I set quit equal to the output of handle input, because usually I have handle input handle the queue. So if a user inputs queue, then the game quits. And I can go ahead and write that out, generate this method. We'll just go ahead and say that we're going to switch on the character key, console key even, and case Q, which is console key dot Q, capital Q. We're going to return true, which means to quit. So actually, let me, well, do I want to do that? No, I think I'll leave it as is. I think I'll leave it as is. Okay. And the else case here is return false. Okay. I could also put this in default if I wanted to, but that would break the other cases. So putting it below the switch statement is actually a better place for it to go. So we should now be able to run. We'll be able to run through our event loop. 2525, press any key to continue. Make as much money as you can in your 50 measly remaining years. Well, it didn't continue, and it didn't continue because I didn't uncomment it. The little things. So now it prints nothing, which is less than optimal. And it... well, I'm going to need to fix that. Probably. I might console clear. I'll have to think about that. That's a problem. Down here where we have this prompt overriding the other prompt, it's a side effect of the way that I'm handling repositioning the cursor. So presumably we can hit buttons here for the rest of eternity, and it doesn't do anything because we haven't actually requested, or actually haven't printed anything out to the screen yet. But if we type Q, beautiful, it does quit. So we'll go ahead and commit that, as if applied, this commit will provide an input handler which can quit the program. So little steps, little steps. So we don't really have an idea of current location at the moment. It shouldn't be too hard to write that in though. So let's just go ahead and say that we have a thing called location. And start out with, that's going to be, well, we don't really have a good default for it yet. So let's think about that in a second. And when we have one of these locations, we want to be able to console write line location.name. And we want to be able to print a description of that location, so that'll be something like console.writeLine location.description. I don't know yet how I'm going to handle options regarding things you can and can't do. We'll work on that in a second. So we've got this idea of a location. As per usual, we can use the control dot and generate this in a new file. This is going to be a new class of some type. We'll just continue to make these public. Again, mostly because I don't like the word internal and don't want to have to discuss it at great length. Public is sufficient, given that we're only working inside a single assembly here, because it's effectively equivalent. If we were doing this in a real production product, I would stick with internal here. Okay, so location has two things. It has a name, and it has a description. Now, for the sake of argument here, I'm going to avoid properties, because we haven't discussed those yet, and I'm going to just work with standard fields. There is a segment of the world, particularly the Java world, who are strongly of the opinion that if you have fields in a class, they must be private and they need to be accessed using getters and setters. And there are other people, particularly in the C++ camps, who think that if you have a field and there's no particular reason to protect that field, so there's no constraints, if you will, that you could put onto the values in those fields, that you should just make them public. I'm going to go ahead with the latter case. Of course, C# allows us to have our cake and eat it too. We can use properties which act like getters and setters, except when you don't have anything in terms of constraints to apply to those fields, in which case they act just like a public field. So again, for the sake of not having to play with public fields today, I'll just go ahead and make these public, or excuse me, sake of not having to play with properties today, I'm going ahead and make these public fields, and we'll work from there. So we have a name and description. I want to be able to create objects of this type using a constructor. I don't want to have to manually set name and description every time that I do this. So we'll create a new location constructor that's public location. It'll be a 2-argument constructor because I want to take both string name as well as string description. And this dot name will equal name, and this dot description will equal description. Undo. Okay, and that allows us to make multiple locations. So let's go ahead here and say that our first location is going to be a new location, which takes the name Earth and is described as a pale blue dot, even at your close distance. The birthplace of mankind, now deserted. Because again, fiction. Monogame? I'm not familiar with monogame. Well, that didn't work at all, did it? Let's go ahead and console.clear. Okay. Beautiful. So we now are able to print the current location. Every time that we hit any key, the entire screen redraws, which you can almost see as I mash on the space button here. And we can hit Q to quit. So I do want to maybe do a little bit of cleanup when I quit the game. What is going on here? Okay, that's better. Or at least a little bit of typing here. So we'll call that closing message. Okay, and that'll be part of the story as well. Okay, so obviously that doesn't exist yet. You know what? I think I may go ahead and create a new enum that describes reasons for quitting. I think I'll go ahead and do that. So, where should I put that? I'll put it at namespace scope. I think I can do that. So I'm going to call this enum quit reason. This is going to contain multiple different reasons that we might be quitting. The first option that we're going to have is we're not quitting. This will be equivalent to the false state that is in our current quit setup. So currently it's basically if not quit. And we're going to change that to if quit does not equal the not quit state. We'll just call it don't quit. So while quit is not equal, or well, quit equals don't quit. And we do have to provide that its fully qualified name. So that will be quit reason dot don't quit. Right, because that's not right yet. That's okay. We'll say var here, and we'll say don't quit here. And it has to be fully qualified. Okay. This has to return a quit reason. We're just walking through fixing all the red squigglies, and then I will go back and fix or I will just make a commit here so that we have this state saved. Let's see. So in the case that we hit Q, we can't return don't quit, which is the false case. So don't quit. We need a new thing to describe what we want to have happen when we hit the Q button. And that will be, we'll just call that user quit because the user has requested us to quit the game. And that is, again, quit reason dot and quit reason dot. Unfortunately, enums have to be fully qualified. I would like it if there were a way around that because it's a bit long, but beggars can't be choosers, I suppose. Okay. So we are going to return quit from this because that will tell us the reason that we quit, which will be enough for us to write the story for each of our 3, or well, at the moment it's 2, but I'm sure that it will actually end up being 4 since we also have to handle out of money and age. So I can just go ahead and add those in there. Age and out of money. And so we can handle all 4 of these conditions, or all 3 of these conditions, based on that enum in our story, which we're about to write. So this has to be quit reason, and then we need to return quit reason here. So basically I'm just threading this quit reason, which is just called quit here, through my entire program. And I can rename it though. We'll call it quit reason. There we go. And that's Control RR for those who don't recall. So closing message doesn't exist. We'll go ahead and generate it. And that will be in story.cs. So let's go over there. Again, make this public. We'll go ahead and switch on quit reason. And actually, it should be able to, oh yeah, that's fantastic. So if we control dot at the end of this switch, it will actually add in all the things we want for us. So it will add the missing cases, which are the cases we don't currently have, obviously all of them. it will add the default case, which is just default, or it will add both. And so we don't need the default case because there are only 4 options here. And so we'll just go ahead and add the missing cases. So don't quit is a pathological case. This should never exist. So we will, we'll just throw an exception here. We'll throw a not implemented exception because it's not expected to be implemented. There may actually be a better exception to throw in this case, but I can't think of it off the top of my head. Some sort of logic error exception. So we'll just say shouldn't be quitting with don't quit reason. And we're going to add this down to the bottom. There is a trivial, so it's not truly necessary from a performance perspective, but there is a trivial cost in looking this don't quit up first. So I'd rather just put it at the bottom because honestly, we should never see this called in this method ever. You should never, ever, for any reason, have to be able to pass, or be able to pass, I should say, don't quit as the quit reason, at least as written by us. And since this is an internal library for this one application, I'm not too worried about people misusing it badly. I do have to say new here. Beautiful. Okay, and so now I've got 3 other occasions, and I can print these as separate methods, or I can just go ahead and print individual lines out. So probably here, I'll print an individual line because this one's short. So we'll just print sorry to see you go. And then we'll have some other good reasons, or good comments here for age. You're 70 years old. We'll go ahead and say that we'll be nice to these people and say that they're retiring. Got a little bit of spacing. And the last one is your last penny spent. A debtor's prison colony awaits. Your remaining years. Something like that. Because fiction. No, where are my build errors? Thank you. Static void closing message. Why are you a problem? Because quit reason isn't available. That's 100% fair. I'm going to try and refactor quit reason into its own thing. Let's see if I can just do that. Well, it does need to be public. But I should still be able to move it into its own place. I can't. We will make it its nice little new file here. We can add a new item. That's going to be an enum, which doesn't appear to be in the list. So we will just call it quit reason.cs. And we'll paste it there. Cool. That should fix our error. Does. And we should now be able to run. We can sit here and press space as much as we want. If we hit Q, it says sorry to see you go. I should console.clear before I do that. So for closing message in our story, we will console.clear in every case. So let's try that one more time. Q, sorry to see you go, press any key to continue. Beautiful. And we'll write this down as add closing message. Okay, so let's take a quick tour of where we are. We have a few classes here. We have program.cs, and that's just our main method effectively, where we call or create a new app object anonymously, and then we call the run method in that object. So run is in the class app, Run just calls the intro story, works on the event loop until the user chooses to quit or there's another quit reason, and then prints a closing message, which we just saw. Both the intro and the closing message are here in story. Intro presents 3 screens worth of input and then prompts the user for input to go between screens. And closing message, closing message prints an appropriate closing message depending on which reason your program ended. Let's go over to UI. That will show us the elicit input. UI is another static class. You may have noticed that story is a static class. This is because we don't have any data that is associated with these methods, and so they can be called as static. All they do is access static methods, like all these console methods here, and UI, which is also a static method, because the only thing that UI.elicitInput accesses is also static classes static methods and static fields via static classes. So elicit input prints a basic prompt at the bottom of the screen, and you can specify what you want that prompt to be, as we do in story in the intro, where we say press any key to continue. And it always does that at the very bottom of the screen, using set cursor position to set the cursor at the 0th element, the farthest left, not most farthest, but the farthest left column, and console.window height -1, which is the screen, the bottom line of the screen, because the console.window height would be 1 past the bottom line of the screen. And then we call read key to read a key, passing true to keep it from intercepting that key so it's not printed to the screen, and .key to get just the console key output code. Give me just a sec while I turn the light on. Whoops, my bad. What can you do? Thank you. So where were we? We have a location. So we have a location. Location has a name and a description and a constructor that sets both of those things. We have one location here in app, and that is going to be, that was my fault, sorry about that. We have one location that we're currently working with. Location is going to be the majority of the manipulation that we'll be doing. Is it frozen? That'd be so sad. Oh, good grief, it's running an ad. At least it's running an ad for me because... Oh, okay. I'm not frozen. That's good. Cool. Oh yeah, I'm a bit behind, but that's not bad. Okay, so we have a story intro, we have a story and closing reason, we have a location, we have a basic event loop that basically just clears the screen, prints the current location, and we're going to make that a little more pretty. We'll have it say location is location name using the string interpolation syntax. We will print a description, that word. Description, there we go. We'll print a description of that area, and then now we have to think about options. Pardon me. So the first thing we need to be able to do is go back and forth between locations. At the moment, we only have one location. So we're going to need some sort of way to both print out locations, as well as having more than one, that is, as well as to list how far those locations are from us. I guess the first thing to do there is to print out a basic option list. So let's say that we want to print We'll just say print option list. We'll start with that for now. Doesn't have to be perfect. We're going to generate that. So that gives us a new void method, print option list. And we can write out what our options are here. So we'll console write line, that'll be option 1 is travel to other locations. And we'll go ahead and print in Q here, Q quit. So this will print our option list. If we get a 1, so case console key dot digit 1, then we want to, let's see, we will just call the travel method. Or maybe travel menu. And break. So travel menu doesn't exist. We can make that exist by using control dot. That gives us a travel menu. And we can, here, let me move some windows around here. Okay, that's better. And we can actually print that travel menu from here. So in the travel menu, we want to print all of our locations. So for each var location in locations, which doesn't exist yet, so we'll come back to it. We want to print basically this information here. So the location name. And we want to print the distance to the current location. So the distance from where we are to the possible locations we could go. So we'll say location.name and current location.distance to, and actually I'm going to pull this out and put it into a variable because it's a bit long. Dot distance to location. We'll call location here destination to make it a little more clear what's going on. There we go. So a lot of this stuff doesn't exist yet. We're going to make it exist. Before we do that, we'll go ahead and make a new var distance here, which is going to be equal to that. Back. Okay. Distance, and this is going to be in light years. And what's the last thing we want to do? Well, we're going to have to put some numbers in here. That's a bit annoying. So we'll say travel to. Switch this to a for loop. And this for loop, we're going to have an int I equals 0. I is less than locations. Locations.length or .count, because it's going to be a list, and ++ I. And so now we will go ahead and print out I + 1, so that we have a number that the user can use to specify which planet they want to go to. So this will be starting at 1 and moving up from there. They'll have a name for that destination. They will have a distance that that destination is away. And we can do some sorting there to make that a little easier at some point. So we don't have a lot of these methods yet. We don't have most of these methods yet, but we're going to. So first things first, let's look at locations. What we have currently is location. So to have more than one location, we would need to make this into, for example, a list. So if we say list of location called locations, we're going to have to hit control dot here and tell it to use systems.collections.generic, because otherwise it doesn't know what a list is. And then rather than saying location is equal to something, we can say locations.add a new location. Okay. And now we're also going to need to reference a current location. So location, current location. And we'll just go ahead and set that to the 0th index, which we know is Earth because we're hard coding these. Undo. this is saying that we're going to look at the current location, which is a reference to a location object, and we're going to set that equal to the reference that exists at the 0th element of the locations list, which we know is Earth because we just added it as the first thing, or the 0th thing, or the thing at the 0th index in this list. So we can now change this to current location, and this to current location. And everything that we've written thus far should continue to work the way that it has always. Now, we can't compile yet, so it's obviously not going to work yet, but soon. So we're going to go ahead and make a new location reference here as well. Location destination equals locations at I. That's just to keep us from having to count or type out locations at I every time that we want to talk about the destination. The last thing we have is this distance 2, which doesn't currently exist. So I'm going to create a new method that does that. This will return a double, and it will be a public method. So we don't have currently a concept of some sort of grid that describes how space works. I'm going to just describe space as a standard Euclidean plane, so a two-dimensional space, with Earth being at location 0, 0, and all the other planets being arrayed around it at a variety of positive and negative double precision light-year locations. So we'll say double xpos equals 0.0, and double ypos equals 0.0, which is the defaults for Earth. We'll go ahead and change this constructor here so that we have to provide these, and then we'll remove the defaults that I just put in there because I don't like them anymore. They didn't last long. So we'll have double xpos and double ypos, and we'll say this dot x position equals x position, and this dot y position equals y position. Beautiful. So we know what the distance between 2 points in a Pythagorean, or excuse me, in a Euclidean space is, and that's the output of the Pythagorean theorem. So we should be able to say something along the lines of destination dot x position minus, well, actually we'll use our location and then we'll subtract from that. So this dot x position minus destination dot x position, and if we say var left equals this, and we math dot pow that times 2, or to the second power, I should say, we should be able to do that. We'll have the same thing for right, except we'll call it right. Just a little bit of prettification here. This is now going to be the y position and destination dot y position. And then we return math dot square root of left plus right. Well, that doesn't quite work. There we go. And that should be the Pythagorean theorem. And that should give us our distance between 2 places, with any luck. So we still can't make this run. Why can't we make this run? Let's look at app.cs and figure out why. Well, I don't see it. Not right off. Right, well, I haven't updated this constructor yet. So we can say 0, 0. Ooh. 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 Fun. Okay, so this tells us where our error is. I tried to run this. Clearly there's a problem. I haven't defined something yet. There's an object reference that's not set to an instance of an object. That's going to be in the constructor, that's what CTOR means, of the application on line 14. And so we can look at that. Oh look, it's right here. Well, what's your deal? New location Earth. Ah, well, locations is a list of things, but we didn't actually initialize that list at all. I'm going to just initialize it up here inside the class scope by saying new list of location and calling the default constructor there. Ooh. Well, that was interesting. Let's try that again. That was weird. Oh, that's really weird. I had to press a button to make it go into this first screen last time, and I don't now. That must have been something going wrong with the console. Okay, so this looks pretty good. We do clearly need a little bit of white space here after the description. We do have our two options here, 1 and Q. We hit 1, well, it just brings us right back here, so clearly something's wrong there. If we hit Q, it says sorry to see you go, and allows us to quit, so that's good at least. So, we'll just add a console write line to the beginning of the option list here. That will give it an extra space. So let's look down at the travel menu. That's why. When we do the travel menu, it doesn't stop for user input. So we'll just go ahead and stop for user input. Well, I don't need you there. And this should be sufficient. So we'll now elicit user input. It's UI.elicit input. Much better. And if we hit 1, that gives us just the Earth, which we're already at Earth, obviously, so we have 0 light years to Earth. That doesn't quite do everything that I would like. So let's start with the console.clear. I think that should clear it up, no pun intended. We travel to the locations. Beautiful. So we can now travel to Earth, which obviously is a silly place to travel. And we have no other places to travel, which is very sad. Let's make a nice little commit here. We'll say add the travel menu. So if applied, this commit will add the travel menu. And we will add a few more locations. So we did have a requirement. If we look down here, we have a requirement that we implement Earth, Alpha Centauri 3, and at least one other. Let's just go ahead and implement both of those other two things that we need. So it's Earth or locations.add, new location, Alpha Centauri 3, the new home world of the human race, such as it is. I don't know why this is sounding more and more dystopian the more I write, but that's just the way of things. We're going to say that Alpha Centauri is, since it is the new homeworld of the humans, it's going to be based entirely along the y-axis. So it will be at x equals 0, and it will be approximately Alpha Centauri away from us, which is somewhere in the area of 4.37 light years. Let me look it up real fast. And we'll just go to the star rather than going to anywhere else. So yeah, 4.367, I suppose we can be that 1 decimal digit more precise. And so this should be 4.367 light years from Earth, just by definition, because it's only in one dimension. It must be 4.367 away. And we'll add one more place, locations.add. I don't know, we'll say a new location, and we will call it Pi Planet. And which design patterns would you like me to use, Villeman? We'll go ahead and put that at math.pi by math.pi, because that's a fun thing to have. And we'll just say it's the planet of pi. Because who doesn't like pi? And so now if we choose to travel to other locations, we should have a variety of options. I don't like how many decimal digits we have here. I'm willing to go ahead and allow 3 or maybe 2 decimal digits, but it seems really overkill to have that many. Fortunately, we can correct this fairly easily, just by changing the distance, or how the distance is written. So we can say 2f. Well, that didn't quite do it. Let's see. I may look into some design patterns for this. Honestly, they're probably going to be overkill for what we're doing here. I would probably go for building interfaces to interface everything together and then go with a dependency injection scheme before I went for, honestly, any of the design patterns that you just listed for this program. Now, I do tend to be a pretty... I'm not particularly an ideologue about design patterns, let's put it that way. Thank you. So I tend to use design patterns when they're the best thing to use, and then I don't use them when they aren't. So your mileage may vary. So F2, thank you, Kilior. F2 gives me the 2 decimal digits that I was looking for here. There's some other things that we could do, like trying to cut out Earth, but for the moment, let's just go ahead and leave Earth in there as a place that you can go, even if you're already at Earth. It's just not going to take you any time to go there, which I think is fair enough. Oof. So we can refactor this into a nice little method called print locations or print distances, print locations and distances. Let's go with that one, print locations and distances. Then we're going to elicit input, which we're going to store into a var key, curry of our key. We'll switch on that key. And then we have a couple of options here. Well, actually, is switch the right thing to do? Switch might actually be the right thing, or might not be the right thing to do here. Let's do this instead. First things first, we want to do this until we get valid input. So we're going to make a new var, which is called valid. We're going to set it equal to false, and then we will do while not valid. So there's a few options that we have here. We could create a new method to handle this, but we may refactor that later. We're not at the moment. The first thing to do is to determine whether we have a valid input. So if valid location key, well, this is a bit awkward because I don't actually want the key itself here. I want the character for the key, or potentially I want the digit version of the key. Also, if we end up having a lot of planets, it's possible that I won't be able to put them necessarily even on one screen, and definitely not on one, or the 0 through 9 digits. So it's possible here that I want to go to the alphabet. Or, alternatively, I could do a selector, like I've done in, like I've done in previous programs, where you can select the actual location you want to travel to using the up and down arrow keys and hitting enter. Lots and lots of options. You know what? Let's just go ahead and build a nice little selector system. It's not going to take much time to build a selector system, and it will make me feel a little bit better about the way that we're handling this. So, we'll go ahead and say valid location key. No, we're not going to do that. So we're going to switch on the key. We are actually going to switch in this case because there are a few things that we will need to manipulate. Okay, so we're going to have a selector. That's the first thing to note. The selector is going to be an int, and it's going to equal 0 to begin. We're going to pass the selector into the print distances and locations to specify which of these things is selected to begin with. So we'll call it a selector. So in this case, we will say if, be quiet phone, if I equals selector, then we're going, whoa, that wasn't what I was looking for, which is going to be an int parameter that's passed in here. Then we're going to invert the color scheme in the console. What's the best way to do this? Well, I'm going to assume a knowledge of the console color scheme, and it will just have to do for the moment. We could actually go a little deeper into this and make sure that we store the color scheme. Let me move this up so it's a bit more visible. We could set it so that we store this color scheme and then we restore from those stored variables. It's not truly necessary. So we'll say that console.foreground color is going to be equal to console.black, or console color, excuse me. Come on, console color. .black, and we're going to say that console.background color is going to be equal to console color.gray with an A. And I'm going to copy this, paste it down here at the bottom, and we'll just swap around which ones are which, so that this always goes back to the appropriate color scheme when appropriate. So we'll run this. It's going to break horribly. Beautiful. So we now have a selected item, Earth. Now we technically don't even need item numbers, but I'm going to leave them in for the moment because I think they make it look a little better. I will say that I don't want to do this. Now I'm getting really picky. We'll do this instead. And then we will do a console.writeLine where we do that. Not sure what happened here. Word wrap apparently bit me. Please don't do that. Thank you. And we're going to put this here. Okay, now it's looking a bit yucky, but we'll be able to fix that in a sec. Okay. Beautiful, beautiful. Well, not quite beautiful, but getting closer. That should do it. Yeah, that's much better. If we're feeling really, really enterprising, I would make all these be a fixed width, but we'll come back to that another time. So we're going to cut this out, put it in its new method, and we're going to call that UI dot, well, we can't call it that yet, but we'll call it extract. Oh no, we'll call that highlight. Highlight. Yeah, I like highlight. Apply. That's UI.highlight because we're going to move this to the UI class. Exit there. Flip UI. And they can go in here with console key. So that'll be that. And we'll do the same thing here, except we will call this reset colors. And it'll be UI dot. Move it as well. Look over here to UI. And it will need to be public in both these cases. Okay. So that gives us multiple locations. Yes, it will. My concern is that it might reset the other things I have listed here, and I'm not certain that's the case. So let me try it. Oh, come here. Okay, that seems to work. I'm happy with that. So we can go ahead and dump that. Works for me. And of course we could extract out what our highlight colors are, background and foreground. The one thing that I do like about my reset color is that I can change what those colors should be. Let's go ahead and say that instead I'm just going to our background equals console dot background color, and var foreground equals console dot foreground color, and then I'll just swap these. And that way I'll be playing nicely with console.reset color. Okay, and so I'm going to continue using UI.reset colors because the terminology means a little more to me, and it means that we're actually working through our UI, which I would eventually like everything to do, quite frankly. And then we will just call reset color from console inside UI. So we're kind of encapsulating that capability, hiding it from the user, and making our UI a little more generic in the process, which is a good thing. This is never going to be an application that is completely divorced from the console, simply because I don't want to rewrite this to have an output system and to have a different method of dealing with input than the console key. It's a thing that could be done, not a thing that will be done, just due to time constraints. Okay. So we have a few cases that can happen with switching on keys. We have the case of a console down. You know what? Before I do that, let me take a quick look at what changes we've made, and then I will make a commit here. So we changed UI by adding in coloring, highlighting, and we changed app by adding in new locations. Make a quick commit here. If applied, this commit will add multiple locations and highlighting. Good enough for me. So we have a few cases we can have here. The first case is console key dot down arrow, which will signify the go to the next item in the list. And when that happens, we will say selector equals, well, we'll say selector plus plus, and then we'll say selector mod equals the list of the locations. Well, that's a property, so we don't need the parens. And break. So let's give this a quick try. So now if I hit down, it should wrap around the list. It does appear to do that. Beautiful. Q doesn't do anything at this point. We do want that to do something. Even though we aren't going to tell the user that we're providing that functionality, we're going to go ahead and do it anyway. So case Q, and just give them that consistent look and feel, if you will, the UX, if you won't, between individual screens. So Q will just back you out of whatever screen you're currently on. We're going to say break here, and we're going to say that valid equals true. Or, you know what, I'm going to change this to done. To done. So done equals true. It's a bit more descriptive of what it is. Okay, next things next, we have the console key dot up arrow. Console key dot up arrow is going to remove one from the selector. So selector minus minus, And then that needs to be combined with the sorry, words are escaping me. It needs to be combined with the locations. So I think if we say selector equals selector plus locations.count, and then we mod it by locations.count, that should give us what we want. Let me pull up a quick little C# interactive here and make sure that that is truly what we want. So it's going to be under View, under Other Windows, and it's going to be down here at the bottom with C# interactive. I guess that's pretty visible. Okay, so we're going to say that if we go to 0, which is a reasonable place to be, and we say that we have 3 things on our list, so locations.count is 3, so 0 plus 3 is 3, and if we then mod that by the length, which is still 3, we should get 0 in that case. Beautiful. So if we do 1 as our index, that should give us, whoa, there we go. That should give us 1, just like we would like, and I imagine so on with the others. And if this is -1, well, that didn't work either. You have to hit Control-Enter to get it to do the right thing here. That brings us to 2, and 2 is going to be the last index that is valid in a 3-element list or array. So that is what we want. And we'll say selector equals selector plus 3, or plus locations.count, mod locations.count. Okay, so I've used locations.count 3 times now. I don't like that. We'll introduce local, and we will call it count. Sure. That should work great. We can move that all the way up here, as locations.count will not be changing during the entire run of the program. We can even say const, because not only will it not be changed, well, it doesn't really matter whether it'll be changed during the program or not. What? Oh, it must be constant. Oh, well, it's annoying. I would like it to be constant just for this method, but apparently it won't let me do that. Okay, and that will allow us to hit the down arrow. We can check that. 1, down arrow, and the up arrow. Ooh, that broke everything. Hooray. We may need to check why that is, but let's see. Select minus minus, selector equals selector plus count, mod count. I think it's because of this. Yes, because mod has a higher precedence than the addition operator does. Okay, so now we can go up the list and we can go down the list. Beautiful. And quit does get us out of the screen, which is exactly what we want. So now we only have one case left, and that would be the case where they actually select this. So I'm going to say selection is done with enter or with the right arrow key. So console key dot right arrow or enter. And we can nest these together. We'll put a break here. We can nest these together without a break in between, and if we hit either of these cases, so either the right arrow or the enter key, it will fall through the other. So if we hit right arrow, it will fall through enter, and it will do the things in the intersection. So for the sake of argument, I'm just going to say done equals true. And this is going to allow me to test both the enter key and the right arrow key. So we'll say 1. I'm going to go down just a few and hit the right arrow key. And that did appear to work. And we'll go down just a few and we'll hit the enter key. And that also does appear to work. It doesn't do anything yet. We'll get to it. Okay, so we'll say this is adding basic controls for the travel menu. And we'll commit all. And the last thing we want to do, at least for this section, is we want to change the current location. So when we change locations, let me think. When we change locations, the big thing that we want to do is we want to update the current location. When we update the current location, we need to do a few things. Specifically, we need to figure out how far the distance is between those two things. We need to ask for a speed between which, or at which the user would like to transition between those two places. And we need to update the age of that user based off of the speed that they have traveled at. So that's a lot of stuff. Let's start just with a method that will do the changing for us. I think at this point, we can't continue without having some idea of a player. So the actual user, the actual individual who's going to be using this application. We'll call that player hero, and that hero is going to have a travel to method. And when they travel to somewhere, we're going to ask them to travel to locations at selector, which should be a reasonable thing to do. So hero doesn't exist. We're going to make that a class scope, and we're actually going to move the current location into that player because the location is kind of a vague thing. If we assign a location to a player, that makes a lot of sense. If we just have this location sitting here at class scope in this app, not as much sense. So we'll do this. Player hero. And we will change the current location to be something inside of this player. We can use the control dot to generate player in a new file, which we can then open up over here. We'll have a location current location, which is a private field inside this class. And we will set that based off of the, well, it's not inside the class, it's inside the namespace. Go where you belong, please. We will set this via a new player constructor. So that will be public player, which takes a single location, and we'll just call it current location. And in fact, we can change this just to call it location because it is clear from context what we mean. We don't have to say current location, we can just call it location. So this dot location equals location. All fine and dandy, just like regular. Now app.cs is going to blow up, but that's okay. The first thing we'll do is set our hero equal to a new hero. So hero equals new player. And he's going to start in, or she is going to start in location 0, which is what we just specified here. Let's see. We're going to make that public just for the sake of argument. There's no reason not to at this time. Again, if we were using properties here, I would make a public getter and a private setter, and then I would have that travel to method. Or I could create the set using the setter, using the property, and then have it call travel to. Either way will work. But I do want to be explicit about that here, but I'm going to make it public anyway. So this will be hero.location.name, and this is hero.location.description. These could possibly even move into the location itself as a print description of location effectively. But I don't really want to include the console.writeLine that deep in the program. Nothing really that deep should know about the user interface. So I'm going to leave it here for now. Okay. So most of the other things in here seem to be okay. So hero.location.distance-destination. Okay, I'm happy with all that. Beautiful. Okay, so travel to is the only thing we haven't built here. I can just generate that method using the standard control dot mechanism. Undo. Travel to is going to eventually change the location, this dot location, equal to the location that was passed in, which I'm actually going to refer to as the destination, just to make it clear what's going on. But there's an additional thing that we need to do here. We need to ask for a speed at which to travel, which I'm actually going to do outside this method because, as mentioned before, nothing this deep in the program should actually care about the user interface at all. And I'm going to update the age of this user, which is not a thing that currently exists, with a warp equation. So let's start off with the age of the user. Again, we'll make this public, and bear in mind, this is not necessarily the best design practice. You shouldn't be making all your variables public all the time, in all likelihood. Usually you don't want people to be able to modify most of these things, and that's mostly what properties are good for in C#. We're doing this mostly because I am going to commit to myself not to abuse this too horribly, more than anything else. I don't necessarily recommend that as a professional practice, however. So we'll say public int age, and we're going to start that at 20. Actually, this will need to be a double because we're going to need more precision than just 20 years of age. I like to have primitive types first. Personal preference. I also prefer double spacing between methods, but I'll spare you from that for the moment. Okay. So the next thing we need to do, we can't just take a distance here. I want to take in a speed as well. So that will be double warp speed. We're going to calculate a time required to travel. Yes, I'm going to calculate a time required to travel between these two distances. So that will be var distance equals this dot, well, we can just say location. Location dot distance to destination. We're going to say var speed in light multiples. And that's going to be something with our warp equation. We haven't actually calculated that yet. So I'm going to create a utility class dot warp speed to light speed. We're going to say speed here as well. That works. And we're going to give it warp speed. So this doesn't exist as mentioned. We can hit control dot and create a new class. This will be a new class utility in a new file. I'm going to make that a static class again, because warp speed to light speed doesn't require storing any data. It's just a utility function effectively. This is going to be internal static, and I'm actually again going to make this public because I don't like the word internal today. And control dot again will generate this method for us. It will automatically create it as a static, so we will have to tell it what to return, which is a double. And it creates that as static because the class here is static, and so it wants to stick with what it knows is correct. It doesn't want to intentionally build broken code. Now, fortunately, I have the warp speed equation down here in my bottom window, my requirements, if you will. We're just going to call this W because it makes the typing a bit shorter in this case. In this case, it's going to be math.pow W and 10.0 divided by 3. I do recall that if we just say 10 divided by 3 here, we're going to get an integer result, which is not what we want. And we're going to add this to math.pow, which is 10 minus W, and negative 11.0 divided by 3. And if I have the link still up, I will check this against the correct values. Let me check around my desktops a little. Way too many of these things. Don't have it up. Let me pull it in another window really fast. Okay, got it. So we'll return here. And well, first off, we could do this using the expression-bodied method syntax, which I do prefer when possible. So let's do that. Control K, Control D makes everything look better. And now we should be able to test this against a couple of different warp speeds. So if we go down here and refresh this, we should be able to say utility dot warp speed to light speed and give it a warp speed, let's say, of 1. Will it work or will it crash? Utility doesn't exist in the current context. So let's try using spacegame.utility. That is a... Well, I should be able to using spacegame at the very least. Well, this may be because it's a console game rather than being a class library. Class libraries usually are more amenable to this activity. It is a public static class and a public static method. I don't think you can make namespaces public, but I'll try it anyway. I guess you can't not. Okay, that's good. You can't actually do that. Well, the thing we can do is this. So C# interactive, we'll paste that there. And then we'll just put in for W what we expect. So 1 times the speed of light is going to be, or warp 1, excuse me, should be 1 times the speed of light. And it is pretty close, though not dead on. I'm not super certain that's the way it ought to be. But let's try a few more here. Warp 1 is going to be approximately warp 1. Let's say to a second or a second or third decimal point, it's warp 1. Let's try warp 9 instead, or in addition. 900, warp 900, fantastic. 151738. Well, that's a little odd. It's off of the equation that the website has, but it might still be correct. Let's try 9.99. It's still within, well within a margin of error, but still not exactly what I wanted. This is going to be 9.99 and 9.99. Oh, it's also possible that they're using a different equation. Let's see. They're using, oh, I see. They're using the Berry-Shields equation, which is actually a slightly different equation. We're using the basic equation, which is not a slightly, holy. Berry-Shields goes up much more slowly than the basic equation does. That's impressive. Yeah, that's a little excessive, isn't it? It just goes out of the ballpark after 9.96. Or 9.6, you said it only works until? Well, that's a little unfortunate. It does seem to skyrocket after that. I may switch to the Berry-Shields equation just for the sake of argument. 9.9.6. You know, it's not that hard to rewrite in the Berry-Shields equation, so I'll just rewrite with Berry-Shields. And if you like the Berry-Shields equation more than the other equation, you can go ahead and work with that one. So let me copy it in from the side over here. If it will copy, it might not. That's pretty yucky, but we'll work with it. Okay. Well, what is A in the Berry-Shields equation? A is that. So now we're writing scientific papers, or scientific calculations, where you just have randomly named variables that hang out in your method name and confuse people who come along and see your code as legacy code. So we'll have double capital A equals this, and we'll have double lowercase n equals this value here. And of course, this is all made up values anyway, so it's not like it truly matters which is which, but you know, we may as well do it this way. Oh. Actually, I may go against this one because I don't really feel like doing a log base. Oh, actually, no, it's log base E. I should be able to do that one with a fair degree of ease. It's warp speed. Ooh. This is written all together very poorly. You know what? I'm going to go ahead and stick with the original equation here. And then I'll just limit warp speed to be between 0 and 9.5 for now. Just say that we can't go faster than 9.5. That does mean that we do need to do a little bit of checking. So if W is less than 0, less than or equal to 0, or W is greater than 9.5, then we want to throw a new exception. Argument out of range exception. Almost did an Emacsism there. And we'll do that instead. So this is the standard guard syntax. You know, it's not a specific C# syntax thing, but it's a pretty popular way of writing conditional, or not conditional, but let's just say for the moment remarkable, or obviously in this case exceptional situations. Okay, so this allows us to convert warp speed to light speed. Now if we go back to player, we need to be able to convert warp speed to light speed so that we can divide the distance between where we are and the destination by the speed in light speed. So the speed in light years, that is. Or not light years, but I guess light years per time period. And that is in multiples of the speed of light. And we'll just call it light speed. So in this case, we need to, our classic equation is distance, well, not double. Distance equals speed times, wow, man. Go away, IntelliSense. Times time. D equals S times T. And we currently have the distance and we have the speed. So what we need is the time. So in order to algebraically solve this, we would subtract both sides, or excuse me, divide both sides by S. And we're going to have D distance divided by S, which is speed and speed of light. We'll call it multiples of light speed. You know what, we're just going to call it speed. That works. And we're going to say that time is equal to distance divided by speed. So this is going to be a distance in light years and a speed in multiples of the speed of light. And so dividing these two together, should give us a year value. So we should just be able to add this directly into age. And we should be able to see that that works if we go back over to app.cs and we print at the very top here our current age. We'll just add it in here with location. No. And we want to do F2 there, just for the sake of argument. So where are our bugs? Let's find the bugs first. No argument. Ah, okay. So we haven't passed into warp speed, which is perfectly all right. We'll just pass into default. So if we want to travel to Earth, then we remain at our current age for the rest of eternity because Earth is our current location. No surprise there. If we go to Alpha Centauri, that's going to give us 24.37 because it's 4.37 light years away, and it's going to take us that much time to actually travel there. Same thing there. We can go to the Pi planet. It's somewhere in the area of 3 years away. And we can now see that we're, it's 3.74 exactly. We can now see that we are older, and if we try and travel there again, it gives us no advantage. Okay, so now we can quit. Now we want to be able to ask for a warp speed. So, if we're traveling, we want to, let's see, we'll do UI. Well, what do we want to do here? We need to input a warp speed. Warp speed has to be between 0, non-inclusive, and 9.5 inclusive. So we do want to have a loop that inputs, elicits this data for us in a fairly clean and straightforward way. So the best way to do that, of course, is to make a new method to do it for us. So var warp speed equals, we'll just say UI.elicit input. That's going to be between 0.0 and 9.5. This isn't a method that currently exists, but we're going to make it exist. And then here we'll call this with warp speed. Yep, I'm going to fix that. So if we go here, we can generate a new method called UI.elicitInput. We already have one of those, of course, but it doesn't take any parameters. This one's going to take parameters. This is going to say bool valid equals false. We're going to do, well, that doesn't belong there, while not valid. And we're going to return some input value. So, yeah. Sure, we'll call it input. Double input equals 0.0. Actually, we'll make it 1.0 because that's a sane default. We should never be returning the default, but it's still a sane default. Unlike 0.0, which is outside of our bounds, at least in our current case. Having said that, if we're going to write this in a generic manner, I'll stick with 0.0. I'd love to be able to not initialize it at all, but the C# checker is not smart enough to realize that we won't leave the loop until that value is set. And it can't really be blamed for that. So we're going to rename these lower and upper, and these will give us some bounds issue or bounds that we can apply to this problem. So let's see, we need to add a prompt in here, string prompt. And in this case, we don't have a reasonable default prompt. I'm going to need to go back to player and provide it, or excuse me, back to app and provide it a prompt here. How fast in warp units would you like to go? Okay, that'll work. Yeah, that'll work. That'll work. Well, we'll make it work. Let's say that. Okay, so we're going to say how fast in warp units would you like to go and put a little question mark there. We're going to additionally use the UI to print out lower and upper bounds here. So we'll say may need to do a little bit of tweaking here, but well, let's see. Now, optimally speaking, we'd have a little bit more of a menu here to give people an idea of how long it's going to take them at certain warp speeds, but I don't really want to implement that. You know what, let me finish implementing what we have set up here, and then I'll go back and take a look at ways I can improve that. So first things we want to do is console.clear, and I'd like not to have to console.clear, but I do have to because we elicit input. And elicit input, the one up here that is, currently doesn't handle resetting the cursor well. I may just need to make it reset the cursor appropriately. Let's see what that looks like. Console.get console.cursor. Oh, well, we can just say console.cursor top. Okay. Let's let's try this. Our cursor pos equals cursor top pos equals that. So we do this, and then I want to console dot cursor top equals cursor top pos. And I guess technically speaking, I ought to save the left position too. Okay, and then what we'll do after we write is set cursor position back to the position it was before we started writing. So cursor left pos and cursor top pos. And I'm primarily doing this because it simplifies the... give me a sec here, sorry. There we go. Much better. Okay, this simplifies the process of handling the cursor in other places. For example, here, down in this list input. Because we don't necessarily always want to clear the screen. Sometimes we want to just print things right underneath everything else. So, we can console.writeLine the prompt. And actually, we don't want to do that. We want to console.write the prompt. And then we want to provide the range lower with F1, let's say, through upper also with F1. I wonder if I should use some sort of set notation here, because we're going to say it's this, I believe. Yeah, I think it's that. I think that'll do. And then we want to elicit input. We'll just do this with console.readLine. And we're going to go ahead and try to first set input equal to double.parse on this value here, whatever's returned. And if that fails, with a format exception, we'll just try again. Not a problem. Okay, let's try this. Nope. Let's try again. Error list, what's your problem? And we do have some additional checking we need to do on input, but that's okay. We'll come back to it. 0 of 1 error. Entire solution, please. Not convert from object to double. I must not have fixed this appropriately. Oh, well, you look at that. That needs to return a double. Beautiful. Okay, so we want to travel to other locations. If we hit down and enter, it asks us how fast in warp units we'd like to go. And gives us a range, which is good. If we put A in, then it just asks us again. And if we put in 1, well, that didn't work, did it? Interesting. Ah, well, I don't actually set the valid value anywhere, so that's going to be a problem. We also need to add a little bit more to this prompt. Let's see. We'll put a write line here. And we will do a value prompt. There. I like that. Let's do this instead. Put the prompt on the line above, and we'll only print it once. Then we will console.write this range set here. and is that gonna work? That needs a close paren. That might work. Delete some stuff here. Let's give this a try. Really, I'm just making this pretty. Whoops, I hit quit. F5. Okay, so if we want to go that one, it's not pretty at all, is it? What's your deal? Oh, I didn't use the string interpolation syntax. That would do it. One more time. One. That one. Range 0 to 9.5. We're going to put that back where it belongs, which is up here. Okay, I like that better. We'll put that there. Okay, and so it'll say how fast do you want to go, and if we say A, it'll do A, and if we want 1, it'll do 1, and if we want 7, it'll do 7, and so forth and so on. Okay, so now I need to do some checking to make sure that this is valid. In general, it will be valid after we receive some sort of valid input that doesn't trigger the try statement, so valid equals true in that case. We will go ahead and add in a check. So if input is greater than lower and input is less than or equal to upper, which is the contract that we have in our user-facing documentation, which is the console.write line that we have, as well as in our minds, or at least in my mind. Okay, so in that case, if it's between the bounds, then we will be able to quit this program or quit this part of the program because this value will be true. So we can say that if we travel to Alpha Centauri by hitting the down arrow, whoa, that's not what I wanted. So we need an escape here. Actually, you know what? There's no escape. Once you choose to go, you have to go. That's what I'm claiming at least. We're going to go ahead and give it 5, let's say. Okay, and we aged 0.02 years. So that did seem to work out. Warp 5 is dramatically faster than Warp 1, so it's not surprising that we aged so little. Okay, I do want to change that in app.cs to say years. And that will be that. Okay. So we've got lots of changes here. I'm going to summarize this as add travel with aging. Okay, so let's take a quick look at our requirements. We are done with console-based. It does console-based. We're done with the warp formula. It does the warp formula. I'm going to say for the sake of argument that we're done with compelling story. We do start at age 20, and we end with quit, out of money, or 70 years old. So we currently end with quit. We don't end with the other two things yet. Still working on that. Okay, so we do have 3 planets, and we don't have an economy at all, so you can't actually purchase anything at the moment, which of course is one of the requirements, though not written. We do have to be able to travel between planets and to trade for goods and or services. So those will be the next things that we write. So before we do that, I want to at least add in the handling for age. We do currently have a age handling system in that our enum, which is over here in quit reason, our enum does have user quit as does have age as a potential method for leaving the program. Let's do a little bit of cleanup here. Let's clean up using statements. Okay. Let's see. Okay, so we have don't quit, we have user quit, we have age, we have out of money. Age is going to be our next mechanism for quitting the program, which we can add in fairly reasonably. So in our event loop, we have a quit reason here. So we have while quit reason equals quit reason dot don't quit. Let's see, we've got a few other circumstances that we may want to quit. And those circumstances are, how best to do this? Okay, so let's say quit reason equals quit reason not equal quit reason dot dot don't quit. This is the ternary operator. I'm not sure this is the best way to do this, but I'm going to play with it for a little bit and see what happens. So we're going to say if the current quit reason is don't quit, so if the user has not chosen to quit, then do an age check. Else, do a, well, just set it equal to quit reason for now. So let's see. The age check is going to check to see if they are an appropriate age, and if so, it's going to return the appropriate quitting symbol, which is age, quit reason.age. So there's one more condition we have to handle here, so it's worth thinking now about how we're going to do that. You know what? Let's just do something a little simpler. Well, no, we can't do that. Shoot. You know what? We're going to do something even worse. I'm going to copy and paste this twice for now. Oh, work with me. Okay. We're going to do age check and we'll do money check as well. Ooh, I think that's ugly. I'm really not fond of this. Okay, we'll do this instead. We'll call a method quit reason equals should quit given quit reason. Let's try that. And in fact, I'm probably going to combine these two together here next, but I'll let that wait a sec. So should quit is going to do a couple of things. If quit reason equals quit reason dot don't quit, then we're going to do some additional checks. Otherwise, we're going to just return quit reason. And the reason for this is that we don't want to overwrite an already existing quit reason. We only want to, specifically the one that comes from handle input in this case, though this should be applicable in any case. We want to just go ahead and return whatever that quit reason is because we don't want to override the quit reason and make it obscure or to potentially obscure what that reason actually was, because we do have different handling in printing the final output message for each of these different quit reasons. So in this case, we want to do an age check. So we'll just say age check. Well, let's think. Arguably, we'd want to do an age check, and we'd want to do a money check as well. Both of which could be methods inside this current method, and in fact, I will make them that way. There's some additional checking we'll need to do. Let's see. Here, we'll just duplicate this. It's a bit hacky. I'm not really fond of it, but we're going to do it anyway. Stop. Okay, so basically this is going to say, we're going to set quit reason here. What was that? So quit reason equals that, and quit reason equals this. Again, there are probably better ways to do this. Most of them involve passing functions around in my mind. I don't immediately see a non-functional answer to this question. So I'm going to leave it as is. And we'll go ahead and write these age check and money check methods inside here. So it's going to be quit reason age check, which is going to, we'll just write this using the expression bodied syntax. So this will be hero dot age is greater than 70, greater than or equal to 70. And quit reason, well, that doesn't make any sense. We have to do this. So if hero.age is greater than or equal to hero.age is greater than or equal to 70, then we're going to do quit reason dot age. Otherwise, we're going to do quit reason dot don't quit. And to be technically true, no, we don't want to do that. I'm sorry. I was going to say that we could return quit reason here, but we don't want to because that would override or that would allow age to potentially override that value, which we don't want. So let's do money check next. We don't actually have money at the moment, so there's no real money to check, but we can go ahead and implement it now because we know roughly what we want. So hero.money equals, is greater than, what did I say my money was going to equal? I believe my technical terminology, actually we're only saying out of money. Less than or equal to 0. And here it doesn't currently have money, so we will generate player field money. Actually, we'll say less than 0 because it's potentially possible you could have $0 and still be in the game. So that will be quit reason dot money, out of money. Otherwise, it'll be quit reason dot don't quit as before. And that should do it. I don't like that method at all. Ugh. Well, that's what I'm going to get. I don't feel like doing additional modification to it, so that's what we're going to get. I'll leave it open. It's not hurting anything. And so the last thing I'm going to do is move this handle input key into should quit. That's mostly because I don't like this repetition of this variable, but technically speaking, it's because anytime that you see the variable like this, you can replace the thing on the right side of the assignment with the locations that variable is used, and it just reduces the need to have that variable. So we'll say that. We'll delete this line, and that will be that. Okay, so if I now, let's say, go to age out, I should be able to travel to the Pi planet at some tiny, minute portion of the speed of sound, some tiny, minute portion of the speed of light, so 0.01, let's say. We're now 70 years old. The time's come for me to retire. Beautiful. And I can press any key to continue. And of course, I don't have a current way to reduce my money, so it's not going to quit. But I'm going to leave that as is for now. So one more thing we need. For each of our locations, we currently just have a list of locations. They don't have any concept of whether things are more or less expensive in those locations. And I'm not going to make anything particularly nuanced for this because it's a bit beyond the scope of the application, and I do want to wrap this up in the next couple of minutes. So let's go ahead and make a double, I don't know, we'll call it the trade rate. And we're going to say that it's equal to 1.0 for now because 1.0 is the default trade rate effectively. And we'll make it double as well. Or excuse me, public. We'll make it public. And that way it can be handled directly from outside the class. You know what? Now that I say that, I don't want to do that. I'm going to make a new method that's going to be called public decimal cost of, and I don't know, we'll pass in an item. An item's not a thing that currently exists, but we will make it to exist. So the cost of an item is going to be the, we'll use the expression body syntax here again, or expression body method syntax, and say that the cost of an item is going to be the item.cost times the trade rate. And obviously this should probably change per item and per location. For the sake of argument, I'm only going to build one item that can be sold in each individual place. Item's not currently a thing that exists. We're going to generate that in a new file, which we have to manually open for some reason. It's going to have a public field called cost. It's going to be a decimal. I did set that equal to decimal in the other one, right? Well, now I've forgotten where it is. It's in player, right? Where'd my player go? That was weird. No, it's not in player. Oh, it's in location. That's why. Yes, so public decimal cost of, that's going to be cost, lowercase c there, times the trade rate, which is going to complain cannot be applied to operands of type decimal and double. We'll just change this to decimal. Hi, how's it going? Okay, so each item is going to have a cost, and it's going to have a name. And we'll be able to set both of these things using a constructor. So public item string name decimal cost. And we're using decimal here rather than double because it's the, if you will, approved way of referring to money because it has better precision than other things. So we will go ahead and do the standard thing. This dot name equals name. Glad to hear it. And this dot cost equals cost. Standard old stuff there. So there's more we need to do. We now have the concept of having an item, and we have a concept of trading an item. We need to determine which items are available at which locations. Which items are available at which locations. What's your deal? What is, it's M, capital M. There we go. If we add the capital M to the end of this 1.0, it goes from being defaulted to a double to being defaulted to a decimal. And it did actually warn us about that, as well as provide the fix for it, which is nice because honestly, I didn't remember what the suffix for a decimal is. So it does say use an M suffix to create a literal of this type. I can just add an M there at the end and it does the right thing, which is beautiful. So let's start off with being able to purchase items for now. So there's a couple of things we need to do to make that happen. First things first, we need to start our player with some quantity of money. We're just going to go ahead and say that they start off life with 1,000 galactic credits. So money equals 1,000. We could probably set this somewhere else. We're doing it here for now. There are two things that a player needs to be able to do. They need to be able to sell something, which will increase their money and decrease their inventory. And they need to be able to buy something, which will do the opposite. It will increase their inventory and decrease their money. So, well, there's a couple ways to go about this. Let's think which is the best. So I can say, well, it's fairly easy to buy things. So let's start off with buying things. So public void buy item. And we're going to take in an item reference called item. And we're going to take the money minus equals location dot is that called? That is called the trade rate. We need to make that public. Actually, we'll call that, we'll use cost of here because that's actually a better way to do this. Location.cost of our item. And then we need to add this to a list of inventory items effectively. So money, or excuse me, inventory dot add item. So money can't be an int, obviously. It needs to be a decimal, which means we need to add this m here, 1000 m. We don't have an inventory yet, so we need to add an inventory. That's going to be a field, which will be a list of items. There we go. I'm actually going to put this, let's see, I'll put that there, and I'll put this here. That'll work. And we do need to add in the generic library to do that. Okay, so now we can buy an item. We still need to be able to sell an item, which again, there's lots of ways to do this. So we're going to have to find one that works with A, the current level of understanding, as well as B, the setup that we have here. So let's think. Let's just type out what we mean and see what comes up. So we can sell an item. And yep, that's okay. So we want to sell an item. We can say, let's say for the sake of argument that we want to sell an item called item. So we're going to pass in a reference to that item and see if we can sell that. So can we say inventory.remove and then get something that allows us to take an item? Well, it looks like we can. Removes the first occurrence of a specific object from list T, which should be a doable thing. Items should be, well, so this specific item reference, excuse me, should be better, or should be able to find what we want in our list and remove it, is the short answer. And we'll see if it doesn't. Is C# better than Java for game programming? I honestly couldn't answer that question with any degree of specificity. I haven't written much Java, maybe 300 lines since I was in college, at which point I threw Java as far away from me as humanly possible. And I've not written any games in C# outside of things on the console like we're demoing here. I would say that Unity's a really great library. So there's definitely a good deal of support for gaming programming in C#. Again, though, I don't know what the Java environment looks like for game programming, so I wouldn't be able to answer that with any accuracy at all. I will say that Minecraft is written in Java, so it's not a bad language. Despite Minecraft's various issues, of course. Okay. So we're going to go ahead and say that we're going to add a quantity of money to the money that we currently have before we remove this item. Money plus equals location dot cost of an item. And we're going to say, for the sake of argument, that we have only one factor for buying and selling. Honestly, if this were a real economy-based system, we would be able to do something like, here's a buying rate and here's a selling rate, and we would probably want to do it for each individual item, which would require some sort of lookup table or a dictionary or something of that nature. Very easy extension past where we are now, just work that I don't necessarily want to do in the next couple of minutes. So this should, in theory, do what we want it to do. Let's just add some items to an inventory somewhere and see if we can make a system that uses this ability to buy and sell items. So the first thing I want to do is, whoa, lost something there. First thing I want to do is add to my constructor here the ability to specify a trade rate so that I can manually specify a couple of these trade rates. So this will be decimal trade rate. And actually we'll default this to 1.0 M. So we can get rid of this one here. And we'll say this dot trade rate equals trade rate, which will use that appropriately. So now all of our locations that we specified up here in app.cs have a default trade rate, and that's going to be 1.0 times your standard cost of any individual item. Let's say that the Planet of Pi is going to have a particularly high trade rate, so something like math.pi, pardon, and that Alpha Centauri 3 is going to have a fairly low trade rate because it's the new homeworld of the human race, and that means that it has everything that humans would generally like to buy. So let's say it's 0.9 or so. That's not the right place for that. And I'm actually going to have to do a cast to convert math.pi to a decimal. Yep, that's what I thought. Okay, so we'll do decimal math.pi. Okay, that ought to do it. 0.9m, and that's this Earth will use the default. What's your deal, quit reason? Why are you being this way? Value assigned to quit reason is never used. Okay, so it can figure out that quit reason is always set. Well, no, it has to be a quit reason. Usually it's not very good at that. Okay. I'm going with it. Okay, so this should run. If this doesn't run, then we've got an issue. It does appear that we do run. Player.money's never assigned to. I assign it right here. Right there. Why, error list? Why are you doing this to me? Player.money is never assigned to and will always have its default value of 0. But we specify it right here. I think the compiler may be wrong about that. So before we go any farther, I want to keep track of the quantity of money we have and just print it out at the top of the screen right next to age. So we'll cut down to one tab here, years, and we'll add credits hero.money. And we will do that with F1, let's say. Okay, so we did need the 2 tabs there. Tabs are tricky little things. They aren't always exactly what you expect. So I'm just going to do 4 spaces here. Good enough for me. So we have location Earth, our age is 20 years, we have 1,000 credits. We can travel to other locations by choosing these places and then choosing to go at a specific warp speed, let's say 5 for the sake of argument. And we could travel to another location here like the Pi Planet. Oh dear, I may remove the... Sure. I'm not super happy with this interface yet. Particularly, I think I'm going to get rid of these 1, 2, 3 because they encourage you to choose 1, 2, or 3. So let's see, how fast in warp units would you like to go? 5. So we can travel around here, and we age not too much at a time, which is nice. Presumably I need to make some other locations that are farther out than these. So a few things I want to do. I want to change illicit input here to just be an empty string, because I'm tired of seeing the little selector at the bottom. And I want to change the print locations to not print out this value here. Instead, we're going to print a space and a dash. Okay, yeah, I think that's much better. Because that doesn't imply that you can select by number. It implies that you actually have to use the arrows. And that does appear to work. Okay, so the next thing we want to be able to do is to purchase something from a location. Let's go ahead and commit this real fast. So this is going to add the basics of trading. And now that we've committed that, we want to be able to console.writeLine. And I could make this into a single trade menu. So trade at this location, effectively. Instead of doing that, I'm going to provide 2 separate menus, a buy menu and a sell menu. So 2 will be buy items, and 3 will be, thank you, sell items. And then I'll make 2 additional menus to handle those 2 additional tasks. And I think I'll go ahead and call it on this particular start of an implementation of the space game. So case console key.d2, and we're going to use the same thing we've been using since the beginning of this, where we're just going to call another method to do this for us, because we never want to implement an entire method at this level in the program. There should never be a reason where we should be doing significant processing in a handle input style method, because it's not the right place. All we should be doing here is handling the input and then vectoring it to the appropriate places for it to be handled further if necessary. Obviously not in cases like where we need to user quit immediately. So in the case of D2, we want to go to the buy menu and break. And in the case of the .D3, the case of pressing the 3 number key, we want to go to the cell menu and break from there. Okay, so buy menu and cell menu don't exist, as you probably have guessed already. We're going to use control dot and generate these this way. So there's 2 things we now need to do. We're going to go ahead and say that the buy menu doesn't exist yet. The reason the buy menu doesn't exist yet is that we will need to figure out which items belong in each location, and we don't currently have a description of that. So instead, I'm going to start the cell menu. The cell menu is going to take the items that the player has in their inventory, the hero. It's going to calculate out what their cost would be on this planet or at this location by using the cost of, I believe, method. That's location.costOf. And then it's going to print the item name, the item description, and the item price out to the screen. Trying to decide if I want to use another selector like this or if I can make this a more generic method so that I can use the selector in multiple places. I imagine I probably can. Let's see, print locations and distances, selector, travel to. Well, it wouldn't be too hard to do if I had inheritance and interfaces, because then I could pass in objects to this that would be printable. And it wouldn't be too hard to do if I had function pointers, because I could just work with function pointers to make this happen, but I don't have either of those things at the moment. So I'm going to re-implement. You know what, just for the sake of making terrible user experience, I'm not going to re-implement. I'm going to provide a different form of user interface. This isn't normally what I would want to do in a final program, but I think it might be helpful to have examples of a couple of different types of building user interface. And so that's going to be the excuse for why I'm going to write it this way. So in the cell menu, we're going to say for int I equals 0 and I is less than the hero.inventory, which apparently is not public. So let me go and check that. Again, this isn't necessarily the way that you want to write things with all of your fields being public. Particularly in this case, you wouldn't want to be able to modify this. And so you'd probably have some sort of a different way of returning this inventory if you were doing it strictly correctly. Let's see, I need to make sure that that is a instantiated thing, which at the moment it is not. So we'll just go ahead and say is equal to a new list of items. Okay, so that is now instantiated appropriately. Okay, and it realizes that it's never signed to because buy item and sell item are never called, which is fine. Back in app.cs. So we have an inventory. Did I call it inventory? I'd call it inventory. So we're going to say here.inventory.count and ++ I. Then for each item in this list, we're going to console.writeLine using the string interpolation syntax to say that we want to print the item or the hero.inventory. You know what? We're not going to do this. Var item equals hero.inventory at I dot. Well, actually, that's all we need. and then we'll say here item.name. We'll do a, I don't know, something like this, item.description. Oh, I don't have description. So item.name, and then we'll do a dash, and we'll say hero.inventory. Well, no, we'll just say cost. So var cost is going to be equal to something. We're going to print the cost here. And we'll put a credits symbol after it, just CR. And before we do this, we will put a I+1. Okay, beautiful. So cost is going to be hero.location.cost of some item, specifically that item, the item that we are pulling out of the list of items. We're using here the standard box notation. So you put square brackets and the index of a thing, and it pulls out of the inventory that specific item, starting at 0. So 0 indexed for lists and arrays in C#. We start at 0, and we count up to, technically speaking, 1 minus the number of items in the inventory. So again, since we're running a little short on time, I'm going to be a little hackier than I would normally be. I'm going to say, which item would you like to sell? We'll make that a console.write. And I'll just accept a console.read line here. So I can, you know what, I'm not going to be too hacky. Not too hacky. We're going to build a little thing here with illicit input, or an additional version of illicit input. Let me actually write what I want to do over here, and then I'll let the IntelliSense system build this illicit input for me. So specifically, I want to input a value that is between 1 and the number of items in the list. So that's going to be a value between, so our item, or let's say int item index, is going to be equal to the illicit input value between 1 and the hero.inventory.count. Okay, so this doesn't currently exist. It's an illicit input that takes 2 ints. And we can move this to UI dot. If I'd actually done this properly, like this, then it would create it in UI for me. So I'm going to do that instead. Ooh, neat. I can use a discard instead. That's kind of fun. We'll talk about this another time. Okay, so now in illicit input, we have yet another illicit input, which is probably down here at the bottom. Tis. We're going to move it up, and back that off. Okay, so this is going to do basically the same thing that we did here, so I'm just going to preemptively copy and paste. Again, bad practice in general, but here we are. And we're going to take a string prompt so that we can print out a prompt. We will need to fix that in app, so this will be this right here. Copy and paste. And so we'll get that item index by saying, which item would you like to sell? So we'll go back to UI here. It'll be prompt. We don't necessarily need range here. I'm going to go ahead and avoid range under the assumption that we will be, it'll be obvious from context. And if that turns out not to be the case, I can add it back in fairly simply. Okay, so we're going to make this an int.parse. It has to be greater than lower, which is going to be this one. And it has to be less than upper, which is going to be this one. And if all these things are true, then it is valid. Okay, so that's yet another handler here, or convenience function, if you will, here. We're going to have an input there. Beautiful. And then at the end, we're going to want to sell So hero.sell item, the item in hero.inventory.count. No, sorry, that doesn't even make sense. We're going to want to sell hero.inventory item index. There we go. So one specific item, specifically the item that is in the inventory at the index that was chosen. And that index does have to be within the realm of reasonable values. Okay, so we've still not done buy menu. We can say with some degree of accuracy what will happen here. Let's just say for the sake of argument that we want to print out all of the things that each location sells. And I'm going to say again for the sake of argument here that we only have one item that we can buy anywhere, and that item is going to be space beer, because why not? So we will say we have a list of items. And what I'm really doing here is modeling what I will be putting into the locations class. We have a list of items, which is going to be equal to a new list of items, which uses the default constructor and contains at least one new item. And that new item is going to be space beer, and it's going to have the low cost of $1.20 per space beer, or 1.2 credits per space beer. Okay, so for each of the items in our buy list, which will eventually be coming out of the location itself, but for now it's just hard-coded in this method, we want to do this loop that we have up top. Scroll up a bit here. So we'll have for int I equals 0, I is less than here, or items dot count, and plus I. And so we're going to print out all the same stuff that we print up here. Except instead of printing it out of the hero inventory now, we're going to print it out of the items list. Oh, incidentally, we have one more thing to check here. Let's do this. We'll say if hero.inventory.any. This is the standard way to check if there is at least one item in the list. It's actually using link, technically speaking. Well, it's normally the way to do it. Well, that may work anyway. We'll come back to it if it doesn't. So, let's see. Let's say that we'll do this here, and else we will do this. Just print a nice little error message here. Nothing to sell, and then we will elicit user input so that we pause. And I'm using press any key to continue often enough that I probably ought to make a different version of elicit input for it, but it's okay for now. We'll do a console.clear at the very top of this. And let's figure out why this isn't working. So hero.inventory list does not contain a definition for any and no accessible extension method any excepting a first argument of type list item could be found. Are you missing a using directive or an assembly reference? Yes, we are. We're missing system.link, and control dot tells us that. So if I use system.link, and this is the only link that I'm going to use, I could also say if hero.inventory.count equals 0, and that would be sufficiently equivalent, honestly speaking. But the long story short here is that we only want to try and sell something if there is something to sell. If there's nothing to sell, then there's no valid input that the user could put in, so they just get stuck on that menu. And so we'll say nothing to sell and let them continue anyway. So we want to do the same kind of thing down here, except that we know, in this case, that there are always going to be items to sell. So again, rather than hero.inventory here, we want to say items. And instead of hero.location.cost of, well, actually, we still want to do that, because we're still looking at the hero's location to determine the cost of any given item. We're still printing out this exact same thing. And actually, we're going to be using this same index code here in our buy method. So there's a lot of overlap here. So which item would you like to buy? And that's going to be between 1 and the item stock count. And last but not least, we're going to, in the case where we get good input, buy an item. And we're going to provide a index into that item list. It'll be items, excuse me. Whoa, that didn't work. It's going to be items dot. Here, we'll do that. There we go. Items dot item index, and we'll buy that. So with any luck, we'll be able to buy and sell items now. And of course, there's additional stuff that can be done here. We could be using the up and down menu options like we're using for traveling. We could be returning some sort of a quit character with Q to specify that we didn't actually purchase something or we didn't actually sell something, but we still want to get out of that menu. Both of these cases, we can't actually do that yet. Those are both things we could do. We'd probably have to build some sort of a struct that would describe whether or not something was purchased and then update appropriately, or return a quit item otherwise, or a quit reason, excuse me. We're not going to do either of those things at this time. This is the minimum effort user interface, if you will. So let's give this a try. Let's see what happens. So it's the year 2525, where man is still alive. You're a merchant of questionable business practices, exiled from your home planet Earth. You captain a space cruiser, the slowest vessel to sail interstellar space. No, I think it should be greater than lower. Though, oh yes, an int upper. You are correct. I apologize. Yes, that should be greater than or equal to. Where did I put that? It's in UI. Yep, you're right. That should be greater than or equal to because this is the integer system. That is not the case for the double system, just because that's how I specified it. And there are probably better ways to notate that as well, particularly with this range context up here. If you don't understand set notation or you don't remember how set notation is done, you're not going to know what that means, and that's fine. We could probably find a better way to describe that to the user. Okay, so we actually already have our application open. I'm going to quit so that we can try that again. Okay, there we go. So again, thanks for that fix. All of our stuff, make as much money as you can in your measly 50 remaining years. And press any key to continue. So we can now buy items. We can only buy one type of item, and it doesn't clear the screen first, so I'm going to quit, and I'm going to fix the clearing of the screen. We can only buy items one at a time as well, which is, in my opinion, suboptimal. So probably the next thing that I would do would be to provide a capability to purchase more than one item at a time. Probably via some sort of a up-down arrow, select the number of items you want. Again, though, lots of things you can do from this point to extend this and make this game better, more fun, more clear, more user-friendly. This is a pretty bare-bones entry-level user interface. Okay, so I want to clear screen here. Normally, I wouldn't put this above, and so I'm not going to. Paste, please. And Control KD. Save. Okay, so that is actually a line wrap. That's good. You know what? Which column is this? Just curious. Column 79. Wow. So this is actually thinner than your standard console. I could make the font a little smaller, but it would be a little less readable on the stream, so I'm going to leave it at its current size. Okay, so we now console.clear there, we console.clear here. The only reason that I would have thought about not putting the console, or excuse me, the only reason I would have thought about putting the console.clear above this items here is that I know that this items is eventually going to be in the location class. So that'll be the last thing that I do, and I'll just say that Space Beer is sold in all three places, and that you can sell any inventory item in every place. So it's 2525, man is still alive, we know all this stuff. We can buy items. We can only buy Space Beer, but we can buy lots of it. Ooh. Ooh. I didn't handle my indexes properly. So, first things first, we have item index, and that needs to be -1. Oh dear. Okay. We have item index, that needs to be -1. That probably implies that I handled it incorrectly up here as well, and I did. So that also needs to be -1. So let's try that again. So we can buy items, we can buy space beer. And now that we have bought space beer, we can see that we have fewer credits than we had before. And we probably have things that we can sell, but I actually want to buy a few more of these. Again, this is not a good buying and selling interface. It does work as expected, it's just not very user-friendly. So now I have 5 space beers. Is that really how many space beers I bought? We're going to quit this program and try again. I'm going to only buy 3 space beers this time, because 5 is too many space beers for one person. Okay, so I do have 3 space beers, and they're each worth 1.2 credits, which is fine. I don't want to sell them here, obviously, because they were probably worth 1.2 credits when I got here. Unfortunately, I haven't provided any sort of queue that would get me out of this menu, so I do have to buy one of them, which is bad, or sell one of them, excuse me, which is bad. We should fix that. I'm going to buy a few more space beers here, so I have lots of space beer to sell, and then we'll go somewhere else. Let's go to the Pie Planet, where everything is expensive, and we'll just go as fast as we can. No, we don't want to do that. We'll go as slow as we can. Warp 2. It's not as slow as we can, but it's pretty slow. We've now traveled almost half a year to get to the Pie Planet. You can see we're on the location in Pie Planet, and the description of the Pie Planet is the planet of Pie. We can now sell items, and we can see that our space beer is worth way more than it used to be worth. It's now worth 3.7699, etc., etc., etc. credits. So clearly we need to do a little bit of rounding, line shortening here to be more explicit as to how much we're actually going to be buying and selling, or how much we'll get to trade these things. And so we can actually come in here and we can sell until we're out of things. And you'll note that we do have now more money than we had before. We're at 1012.8 credits. So obviously this is not a very profitable business, particularly when you can't buy more than one thing at once. If we want to sell items now, it'll tell us nothing to sell and tell us to press any key to continue. And that's that. We can now buy things for 3.7 credits, and we are actually forced to. So we'd have to sell those as well. So a few things I want to do here. I want to first take this cost and format it appropriately. So that will be formatted as an F2, and they'll be in both of these cases. There's probably something here that I can abstract out, given that there is a similarity here. We have a loop that we're going over where we print out exactly the same stuff. We elicit some input based off of a string. We clear before each one. In all likelihood, I could pretty simply abstract that out. Let me just do that. We'll do this. Extract method. That's going to be print items, for the sake of argument, where items is a thing that we pass in, and then we will use that same thing here, because it's the same thing, to print those items from the hero inventory. So print items from hero.inventory. Okay, so now we can print items in a more generic manner. And let's see. Well, how are we going to handle this? There's no good way to handle this at the moment. See, I've got too many methods running around by which I do user interface, unfortunately. If I had stuck with a single one, this would be dramatically easier at this point. Let's, for the sake of argument, say that we want to make a struct that determines whether the user should exit or not. And actually, we're going to set elicit input here in both of these int cases to also include Q as a potential value. So it's going to take a little bit of modification, but that's not too bad. So as part of static class UI, I'm going to make a new struct. We're going to call it int input. And int input is either going to have, it's going to have an int, which is going to be equal to some value. So it's going to be val or int input. And it's going to have a quit reason. Okay, so we're basically just taking two pieces of data and we're smacking them together. So we're going to go ahead and say that there's a constructor here. And the constructor does one of two things. It either takes an input or it takes a quit reason. If it takes the one, it doesn't set the other, and if it takes the other, it doesn't set the one. Or it sets it to a default value, let's say. So we'll need an int input, and this is actually going to be public int input that takes in an int, which we'll call input. And in that case, we want this dot input to equal input, and we want this dot quit reason to equal quit reason dot don't quit. So this is basically the we received good input, don't quit option. And then the second one we'll have is going to be, well, actually we're going to change this slightly. We'll call it bool canceled, because we don't actually need all of the full range of potential reasons to quit this program from just inside this method. We only need to know whether the user actually gave us an input or whether they gave us some sort of cancellation value. So in this case, we're going to say canceled, and we're going to set it equal to true, or false, excuse me, because in this case they didn't cancel. And in this case, we're going to take in an int. Let's see, so if we cancel instead, we'll just pass in a bool. So we'll do int input, and we'll say bool canceled. And in that case, we'll say input equals 0.0, or just 0, I suppose, because it's an int. And actually, we'll say -1, because that's a value that should cause havoc if somebody actually tries to use it, if they don't check for canceled. I like havoc, so that's good. We'll say this dot input, and we'll say this dot canceled equals true, or it can equal canceled. That's actually a better value for it. And so what this really comes down to is it's the default. You know what? I'm just going to make this a no argument constructor and have it call itself like that. Oh, right, it's a struct. We can't make a no argument constructor. It's fun. So we'll just say bool canceled. And this will be canceled. That'll work. And so in this case here, where we're taking in an int, we actually don't want to do an int. We want to do an int input. And then we have a couple things we need to return. We need to say return, well, let's see. We're going to say struct. Nope, not struct. We're going to say int input. And I'm pretty sure that in here we can say, well, we'll call this output actually. Okay, and then we can declare input in there. That's beautiful. We should do this first. And we'll do if input equals q, the letter q, string q, then we will say that output is equal to a new int input with true as its parameter. That should work. It does appear to work. That's good. And we need double equals there. There we go. Else, let's see. So else, we're actually going to put this all inside of another block. And we're going to try to convert this. So that's var, we'll just call it I, equals int.parse the input. Which, if it's not valid, we've already checked for Q, so the Q situation is handled appropriately. But if it's not valid at this point, it will throw a format exception. Oh, we also need to say valid equals true here. Otherwise, we never exit. So in here, we're going to try to do the int.parse. We'll say if I is less than or equal to lower and it's less than or equal to upper, then valid equals true. And we'll go ahead and say that output equals a new int input with the value of I. And then we'll output here. So it isn't aware that output will ever be assigned, which is not too surprising. So we'll just say that's equal to a new output, not output, what the heck, int input. This is how I can tell that it's about time for me to stop. I'm starting to lose my mind. Okay, which should work all there. Let's see what's here. So this is saying that this struct is less accessible than the public static class. So we actually do have to make this a public struct, int input. And I may even move that outside of UI. We'll see how it actually works when we try and use it. So what we have here now is not going to be this. It's not going to be an int anymore. It's going to be a var. And we have the same thing going on in the cell menu, so that's also a var. And basically we just need to add in a new if statement here. So if not item index dot canceled. Well, it's not public, so we can't access it. Let's go back to UI here. We'll make both of these public. Back to app, so item.canceled. So if it's not canceled, then do the cell. And that's going to be item index dot value, which I think I called input, -1. Okay, so we need the same thing down here. And I do want curly brackets here because lacking curly brackets is a bad thing. Don't do it if you can help it, even though it does make your code 2 lines longer and a little bit uglier, if I'm being perfectly honest. So we want to do the same thing here. This is .input. We're going to have some brackets here at the end. We're going to have a bracket here at the beginning. If item index dot canceled, and a bracket there. Control KD to fix everything, and it's not item index dot canceled. So now if we run this, we should be able to buy items and quit out of this menu, which we now can, which is beautiful. We should be able to quit out of that one as well. We didn't actually write the code to handle that. The code to handle that would be the exact same as the code we already wrote, except in that case, it would be a double input instead of an int input. Now, technically speaking, if we wanted to do this properly, we would have some sort of a generic that we were using. But again, we haven't covered generics yet, so I'm not going to go into them. But that would allow us to have a single cancelable input struct, effectively, that allows us to cancel input off of a menu, as you would expect. And then we'd have to check for that in app.cs. Okay, so let's see what we can do here. I seem to recall that we had a problem with buying items, so let's buy a space beer here and then travel to Alpha Centauri there. Let's say at warp 5. Oh no, this was on Pi Planet that I had this problem, so we buy an item here. I should have quit out of there. Oh well, what can you do? And then we travel to the Pi Planet. We can now sell items and we can buy items, and that's beautiful. It does exactly what we want. So we could buy 2 space beers, or we could buy space beers or sell 1 or more space beer here. Okay, so the last thing that I wanted to do was to move the actual item lists into the individual classes or individual location objects, because I want to be able to pull out of that. So we're going to say here hero.location.items. And this is going to be hero.location.items.count. And this is going to be hero.location.items. None of which is particularly nice. I probably could have cut that down quite a bit. Something like this. You know what? I could actually use IntelliSense to do this for me, I think. Let me try. Oh, well, I'm going to have to create it first, and then I can probably come back and do that to refactor that. So let's go to location. We'll go ahead and create a new list of items. It's going to be public list of items called items. And we'll just go ahead and say it's equal to a new list of. There we go. So we'll have to add in the generics here, or the collections.generic, excuse me, because it doesn't otherwise know. And these are actually called item, not items, so that's going to be a problem. Naming things, one of the 2 hardest problems in computer science. Okay. So, of course, we need to add a field here. This is becoming a pretty ridiculous constructor. I'd want to start refactoring this constructor about at this point. We're going to take a list of items here, though. And then we'll just set this dot items equal to that list of items. And we can move that now. Okay. So if we go back to apps.cs, it does now recognize what we're trying to do here. I should be able to select this whole thing, hit Control-I, and introduce a local for all occurrences of hero.location.items, and we'll just call it items. That automatically does all of the manipulation for us that we needed to do. So anywhere that we used to have hero.location.items in this method, we now just have items. So super duper powerful, super duper handy. Love it a lot. Okay. So the last thing we should need to do is add in a list of items to each of these. These are definitely getting hairy. I'm not super fond of this. Let's try this. Oh, wrong way. New list of item. And that's going to be containing, it's just going to use the default constructor, and it'll contain a certain number of things. I think that's 1 too few parens. It is. And the thing we want to include is something like this space beer here. Copy. Undo, undo, undo. Paste. We're going to cut it down to that. Now this is definitely not the best way to do this. We're hard coding a bunch of stuff here. What we could do is create some items here that are generic items. So var beer equals new item space beer. Or sorry, a new item which we'll call space beer, and which will have a default value of 1.2m. And then we could add another item. So for example, honey equals new item space honey, because everything in space is called a space thing, didn't you know? And let's say that's 3.4m because we have to go steal the honey from the space bees, which is dangerous. And let's add one more thing. What's a good thing to have? Illegal arms. I'm not going to tell you which type of arms these are, just that they're illegal. Because who knows, maybe you want 4 arms, or 6, or 5. And they're quite expensive, which is good. You don't just want anyone buying illegal arms. So it turns out that you can only buy illegal arms on the Pi planet and on Earth, because Earth is an abandoned wasteland. So we'll go ahead and say you can buy beer and illegal arms on Earth. I'm going to space out this one just like I did with the other. C# being white space agnostic, doesn't mind if we do a little bit of spacing. I'd like to do a little more, but unfortunately Oh, I see. Forgot about that. Unfortunately, the largeness of my font at the moment is not allowing that. So we'll say a new list of items that contains, what is this, Alpha Centauri. So in Alpha Centauri, they don't drink, but they do have honey, and that's all they sell, just honey. Okay. And last things last, we'll have a new location called the Pie Planet. The Pie Planet is a pretty liberal, if you will, place to go. So they have illegal arms available. They're liberal on crime, let's say. So they're going to have honey and illegal arms. And heck, why not? They'll have beer too. This is clearly where we all want to retire to. So we can have our honey, illegal arms, and beer. So this gives us all of the things that we can buy from these specific locations. They're now build errors, so we get to go figure out why that is. Right. We have a optional item here. So optional items cannot be anywhere except at the end of lists, which means if you have 5 optional items, they have to all be at the end of parameter lists. Pardon me. So in this case, we have the trade rate, which is an optional item, and we have added something after that, so it's complaining at us. We have to move that decimal trade rate to the end of the parameter list, otherwise everything breaks. Okay, so in here, we're going to need to now fix this. This 0.9 is going to need to go at the end after the list of things we can buy. And same thing here. There we go. So this should now do it with any degree of luck. Does look like it did. So let's work. Welcome to the year 2525, where man is still alive. You're the merchant of questionable business practices, exiled from your home planet Earth. You captain a space cruiser, the slowest vessel to sail interstellar space. Make as much money as you can in your measly 50 remaining years. Which of course isn't that much if you have a ship that can go almost warp 9.5 and you're only going between planets that are about 4 light years apart. You could probably do that trip 1,000 more times and you wouldn't be dead yet. But there's that. So we can now buy items. We can buy space beer or illegal arms. We can't buy any illegal arms because, unfortunately, if we do that, we just immediately go to debtor's prison. It does actually allow us to do that, which might be a problem. Maybe we want to filter out things that are not currently purchasable because we don't have enough money. Or maybe if we actually try and buy something that costs more than our current amount of money, we should go to jail. Who knows? On the other hand, we probably ought to have the total amount of money that is currently available to the user on that screen somewhere. So that might be a upgrade to make in the near future. So let's try and buy some illegal arms. I should be able to buy some items here on Earth. I can buy some space beers, and I should be able to go to the Pie World and sell those space beers and actually make some money. So there we go. I've bought a bunch of those things, and we can see that here in the sell menu. It'd probably be nice to have an inventory menu, but again, time. Everything is time. So we now travel to Alpha Centauri. We can say we'll go warp 5. We should be able to buy items here, and we can only buy space honey. We'll just go back to where we were. No quit in that menu either, I don't think. Oh wait, I do. Never mind, I have quit in that menu. I should have just quit. So now we can buy items. We already bought some items. We could sell some items, but I don't need to. Again, buying items, we only have that 1 space honey to buy. Let's travel to the Pie Planet. We'll go at warp 1 just for the sake of argument, which took us a few years. And now we can sell our items. We should be able to sell each of these in turn. And we can see we actually made some money on our space honey there because of the markup rate. So we don't want to buy illegal arms here on the planet of Pi because the Pi planet has tremendous markups for everything. You can see that illegal arms here cost 3,000 credits and we can barely buy them for that much anywhere. What we can do, however, is we can spend a little bit of time to go to Earth, smarmy place that it is, and buy illegal arms on the cheap, which now brings us down to 24.7 credits, so we could actually buy a few more space beers as well. Being the enterprising people that we are, we can either buy them for resale or for personal use as we travel back to the Pi planet. Fast as our little legs will carry us at Warp 2. And try and sell those items. So we can now sell our illegal arms for quite a bit more than we bought them. And we could even... that messed up. Sell the rest of our things. Now we have nothing to sell. And if we wanted to buy items, we could buy items. We don't want to do that because everything's expensive here. And of course, now if we wanted to travel back to Earth, we could buy more illegal arms. Travel back to Pi planet. Sell those illegal arms. And we could probably end up making quite a bit of money here without too much work. So let's do a quick look over our requirements, and then I'm going to go ahead and say that this is good for now. We do have a console-based application. Let me make this full screen, or at least big. We do have a console-based application. It uses the Star Trek warp formula to take a warp speed in and determine how fast that is in multiples of the speed of light. It has a fairly compelling story. I'm sure it could be better. We do start at age 20. We end when you quit. We end when you're out of money. We saw that. That's the debtor's prison ending, the bad ending, if you will. And we have the 70-year-old ending where you retire from being a space trader. We do have at least 3 planets, and we do have the beginnings of a per-planet economy in that we have some hard-coded value that is the markup or markdown. Now, in the long run, I'd probably like to see a... per inventory item or a per sellable item limit, but for the current time, it's okay as is. Okay, well, I can do that. Nope, that. There we go. I had to find the right keys to do everything. This is a tiling window manager, and it does mostly what it wants to, but if I can find the right keys, it does what I want to as well. So, I think that's about all I want to do today. It's been just over 3 hours. We've got a pretty good amount of the program completed, at least all of the basic requirements. We could go back in here and do more complex things. There's a whole list of stretch requirements, if you will. But I hope that this was useful to generally align you in the right direction. I think the biggest thing to take away here is that most of what we're doing is just describing what we want to do by building out method names and then going in later and implementing those methods, kind of in a top-down approach. It's very, well, I mean, top-down is one of the fundamental ways to handle program creation. So, I mean, that's the way we're doing it. It tends to work really well for me. It works particularly well if you're thinking of your application in the context of just a bunch of functionalities that can happen without thinking too much about the data. I'm glad. Thank you all for joining. Yeah, the mod is a really, really powerful thing, particularly in the case where you have a list of items that you want to manipulate without caring about the ends. So anytime you need to cycle from the beginning to the end of a list, mod is really your friend. So again, I hope this was useful. I will be putting this code on GitHub as soon as I get off the stream. I will additionally be providing this video via YouTube. So hopefully this will be helpful, if not in perpetuity, then at least for the near future.